Welcome back. It's a little cold outside today, so let's warm up with a little video about functions. Today's video on functions is going to be about linear equations, so let's go ahead and get started with that right now. Today we're going to begin the functions unit. Up until now, when we talk about equations, we've been talking about equations that have one variable. Solve for x, solve for y, solve for b. Today our equations are going to have more than one variable, and they have a special name. These type of equations are called linear equations. And a linear equation is an equation that when graphed makes a straight line. So a good way to remember it is linear has the word line in it. If you don't make a straight line when you graph your linear equation, you know that you've made a mistake. Let's take a look at example A. Example A says, given the linear equation, complete the table, then use the ordered pairs to graph the equation. So right now we've got a linear equation that says y equals 2x minus 4. So we've got to figure out points that we can plot on this graph, but they haven't given us any x's and they haven't given us any y's. So what we're going to do is we're going to pick x's and plug them into our equation, or substitute them, and solve for y. So since I get to pick the x's, I'm going to pick things that are easy for me to work with in the equation, because I can pick whatever I want. Do you have to pick the x's that I'm going to pick? No, but you want to make sure that you're going to pick things that stick on the graph. So here, our graph stops at positive 10 and stops at negative 10. So choosing x's that are above 10 or below negative 10 wouldn't be helpful because they wouldn't be on our graph. So we have to pick things that are going to work on our graph. In this case, I'm going to select negative 2 because I want a negative number. I'm going to select 0 because 0 is an easy number to substitute in. I should always pick 0. And positive 2. That way I have a positive number. Again, are these the only numbers I could have chosen? No, but they're the easiest numbers for me to work with. So the first step is to write out my equation missing my x because I'm going to be substituting something in. So I've got y equals 2, and inside the parentheses the first time I'm going to select negative 2 because negative 2 is the first number that I'm substituting in. Then I'm going to simply apply the order of operations. So 2 times negative 2 is negative 4. Negative 4 minus 4 is negative 8. So I know that y is going to equal negative 8. So the first number that I've got is when x is negative 2, y is equal to negative 8. Every time. Every time my x is negative 2, my y is going to be negative 8 in this linear equation. So the next number that I'm going to substitute in is 0 because that's the next number in my table. So I'm going to take my 0 and plug it into my equation, or substitute it. 2 times 0 is 0. 0 minus 4 is negative 4, so I know every time that I have 0 in my linear equation, y is going to equal negative 4. So I can fill that in my table. The last number that I'm going to substitute in is positive 2, because that's the last number in my table. So I'm going to plug in negative 2, or positive 2. 2 times 2 is 4. 4 minus 4 is 0. So I know that every time I took positive 2 into my equation, I'm going to end up with y equals 0. Good news. Now my table is complete. I have 3 sets of ordered pairs, and all of them are going to fall onto my graph. Now, if I pick numbers and I'm doing this substitution and they don't fall on my graph, that's okay. I can do a few things to work around that. I can either pick another number and do it again and hope it lands on the graph, or I can make sure that I have at least 2 points to graph. I need at least 2 points to connect the dots because, again, I'm going to make a line when I graph my linear equation. So let's plot our points and make sure they end up in a line. So negative 2, negative 8, and I put a dot. 0 and negative 4, and I put a dot. And 2 and 0, and I put a dot. Notice that my points make a line, just like I said my linear equation would. If I had a point that ended up way over here, I would not have a line, so I know that point is probably a mistake. So you can always go back and check your work, because if you're graphing points and they don't end up in a line, you know that you've made a mistake in your linear equation. So let's put that 0, negative 4 back where it belongs and draw a line between all of my points. Now, I'm going to make sure that I draw my line all the way through my graph. because just because these are the 3 points that we picked that worked in this linear equation doesn't mean they're the only points that work in my linear equation. Every point on this graph will work, every point that's along this line. But not just points that are on this graph, all points that fall on this line that goes on forever and ever. So to indicate that the line is going on forever and ever, I'm going to make sure that I draw arrows at the end of my line. Every time that I draw a graph, a linear equation, I'm going to draw a line through my points, and I'm going to draw arrows at the end. If you don't draw arrows at the end, your answer will be incorrect. Let's take a look at the next one. Example B says, given the linear equation, complete the table, then use the ordered pairs to graph the equation. So this time they've given me y equals 1/4 x plus 3. So again, I get to pick my x's. There's no x's, there's no y's here. I get to pick whatever I want. But I know every time I plug in one of my x's this time, or substitute it in, I'm going to be multiplying it by 1/4. So in order not to end up with decimals or fractions, I'm going to make sure that whatever number I have is easily divisible by 4, because multiplying by 1/4 and dividing by 4 are the same thing. So I don't want to pick like 1, because 1 times 1/4 will give me 0.25, and I don't really want to graph 0.25. So I'm going to pick numbers that I know are divisible by 4. So again, I'm going to start by selecting a negative number. I'm going to select -8, because -8 is divisible by 4. I'm going to select 0, because no matter what I multiply or divide, 0 is going to give me 0. So that's an easy number to substitute in. And again, I need a positive number, so I'm going to select +4 in this case. Again, are those the only numbers that will work? No. Other numbers that are divisible by 4 will also work. Numbers that are not divisible by 4 will also work, but they are not easy to graph. And you might end up with a question that tells you need to have answers that are integers. And remember, integers can't have fractions or decimals. So any time that I'm given a linear equation with a fraction, I want to make sure that I find numbers that are divisible by that fraction. So if it gives me 1/3, I want to have numbers that are divisible by 3. In this case, it gave me 1/4, so I want numbers that are divisible by 1/4. If it were to give me 1/6, I want numbers that are divisible by 6. So I've selected numbers that are divisible by 4. I've got y equals 1/4. I'm going to substitute in my first number, and in this case, it's -8. So I'm going to take my -8, substitute it into my equation, and I'm going to run the order of operations. So 1/4 times -8 gives me -2. -2 plus 3 is +1. So I know that y equals 1. And again, I don't have to do this math in my head. I have a calculator. I could do 1 divided by 4 in my calculator times -8 plus 3. I don't have to write anything out. I could just use my calculator, and it will give me the correct answer. So I know that any time that I substitute -8 into this equation, I'm going to get +1. Let's take a look at the next substitution. So in this case, I'm going to substitute 0. 1/4 times 0 is 0. 0 plus 3 gives me 3. So any time that I substitute 0, I know I'm going to end up with +3. The last number I need to substitute in is +4. So 1/4 times 4 is 1. 1 plus 3 is 4. So I know anytime I substitute in 4, I'm going to get 4. So now I've got 3 points. Again, all 3 of my points happen to fall on my graph. If they don't, that's okay. I select different points. So I'm going to select, let's see, -8, +1. Zero, 3, and 4, 4. Now again, all my points made a nice neat line. I know that all of my answers work because they're in a line, so I'm going to draw a line straight through. Now again, I'm drawing my line all the way through my graph, and because these problems are going to go on forever and ever, and their answers may not be the only answers that are given here, I need to make sure that I draw arrows on the end of my line. Let's take a look at the next one. Now, example C makes things a little harder. It says, given the linear equation, complete the table, and use the ordered pairs to graph the equation. Unfortunately, this time it doesn't have just y over there by itself and everything else to the other side of the equation. So we're going to have to figure out a different way to go about figuring out the different points. Also this time, we don't get to pick our own points. They gave us some x's, they gave us some y's. The good news is they gave us an x and y ordered pair 1, 2 in the middle of this set, so we know we don't have to do anything there. But we have to figure out one of the x's, and in this case, we've got to figure out one of the y's. So let's start by figuring out one of the x's. So it says -5. So I'm going to write out my equation just as they gave it to me, except this time instead of the x, I'm going to substitute in the -5. Because that's the point we're given. So now I'm going to use the order of operations, and I'm going to end up having to solve an equation because I've got numbers on one side, constants on the other side, and a variable right there. I have to isolate my variable to figure out what my y is going to equal. So 2 times -5 gives me -10. I didn't do anything to the y's, and it still equals 8. So now I've got a two-step equation. I know how to solve two-step equations, so that's good. I've got to get rid of my constants first, and I've got a -10. So I'm going to add 10 to both sides. When I do that, the -10 and +10 are going to cancel, leaving me with 3y on one side, and 8 plus 10 is equal to 18. So now I've got a one-step equation. 3y equals 18. And I know how to solve this. I'm going to divide both sides by 3. And when I do that, 3 divided by 3 is going to cancel out to leave me a y, and 18 divided by 3 is equal to 6. So y equals 6. So I know that when I substitute in my -5, I get 6. So I found my y. That's good. I've done that before though. I figured out how to find y's. I've never figured out how to find an x. But the good news is here, I can apply the same thing. I'm going to just substitute in -2 where the y is, instead of substituting in something for the x. So I'm going to substitute 2x plus 3, substitute in my -2, and I end up with equals 8. So again, I'm going to apply the order of operations and end up solving an equation. 3 times -2 is -6, so I end up with 2x minus 6, and now I've got a two-step equation. I'm going to add 6 to both sides. When I do that, I end up with 2x equals 14. I'm going to divide both sides by 2, and x equals 7. So even though I was given x or y, it didn't matter which one I found. I had to find them the same way, by isolating the other variable, just like we've done when we were solving equations in Unit 5. So I know that every time y equals -2, x equals 7. Good, now I've got my 3 points, so I can make sure, yep, all those points are going to fit on my graph. So let's start graphing them. Pause the video here, graph the points, and draw your line. Then press play again to see if you're correct. Good, hopefully your line looks like mine. Remember, you have to have all the points on the graph, straight line. You can use a ruler for this. And you need to have arrows on the end, because remember, not just these answers work. All of the answers on this line work. Let's take a look at the next one. Example D says, given the linear equation, complete the table, then use the ordered pairs to graph the equation. So again, they haven't isolated one of the variables for us. They put both variables on one side of the equation. Very frustrating. So 5x minus y equals 7. The good news is they've given us some points, so we don't really have to pick our own, so at least that takes the stress off of us. We've got 3, 8, don't have to do anything there, have the ordered pair. 0 and I don't know, and y is going to be -2. So in this case, I'm going to start by figuring out what the x is, and I'm going to leave it to you to figure out what the y is that goes with that 0. So I'm going to start by taking my equation, 5x minus, in this case, they want us to substitute in -2, equals 7. Now, I know that when I have a -2, -2, I'm going to end up with 5x plus 2, because a negative and a minus is going to give me a positive. So now I've got a regular two-step equation. I know how to solve these. I'm going to start by getting rid of the constant by subtracting 2 on both sides. So +2 and -2 cancel each other out, leaving me with 5x, and 7 minus 2 is 5. Now I've got a one-step equation. I'm going to divide both sides by 5, and when I do that, x equals 1. So I know that every time I substitute in -2 here for my y, I'm going to end up getting x equals 1. So now I figured out x. I want you to try and figure out what the y is when x is equal to 0. So I want you to pause the video now, solve for 0. When you're done, press play to see if you're right. Did you get y equals negative 7? Hopefully you did. 5 times 0 is 0. Then you're just left with the negative y. Divide both sides by negative 1 to get rid of that negative, and you end up with y equals negative 7. Excellent. So now we have our points. Let's go ahead and graph them on the board. So we've got 3, 8, over 3, up 8, 0, negative 7, going over left, right, 0, down negative 7, over 1, down negative 2. And again, I've got a nice straight line, so I know that I probably did this correctly. I'm going to bring over my line. Yep, everything's in a nice line. But again, I'm going to make sure that I have arrows on the end because these are not the only answers that work here. Let's take a look at the next one. Alright, this one says, given the linear equation, complete the table, then use the ordered pairs to graph the equation. Again, they've isolated the x, but not the y. This should be pretty easy for us to understand, because again, it doesn't matter whether we're missing the x or the y, we just have to substitute in the pieces we have to solve and find what we need. So what I want you to do now is pause the video and try this one for yourself. When you're done, unpause to see if you're right. So I want you to find the missing x, find the missing y, plot all your points, and graph the line. Let's see if you can take it all the way from the beginning to the end. Pause the video now. Okay, how'd you do? Hopefully you got that when y is negative 2, x equals negative 7, and when x is 2, y equals 1. If you did that, then you've got your points on your line, you've got a nice straight line with arrows at the end. Again, if you don't have a straight edge, grab a ruler. Make sure that you've got a nice straight line to plot your points. Let's take a look at the next one. Alright, let's take a look at the next problem. It says, given the linear equation, complete the table, then use the ordered pairs to graph the equation. Oh no, it's one of those giant division-y problems. I feel like they just don't like us at this point. We've got x minus 8 divided by negative 4 is equal to y. So the good news is they isolated a variable for us. We know that we're just going to plug in, and whatever we do, we're going to get y. The bad news is that they gave us one of the x's missing, so we're going to have to work backwards and solve the equation for that one. So let's start there since it's the hard part. Let's get that out of the way first. So I'm going to have y equals 0 and work backwards from there. So I'm going to start with my equation. X minus 8 all divided by negative 4 equals 0 because I substituted in my 0. Now I want to get that x alone, I want to get rid of that 8, but I can't do any of that because it's all being divided by negative 4. So in order to get rid of negative 4, I have to do the inverse operation. The inverse operation to divide by 4 is to multiply both sides by negative 4. So when I do that, the negative 4 and the negative 4 are going to cancel each other out, and 0 times negative 4 is 0. So that leaves me with x minus 8 equals 0. Well, that's good. It went from a really messy equation to a single step equation real easily. So again, I'm going to add 8 to both sides. And when I do that, negative 8 and positive 8 are going to cancel each other out. 0 plus 8 is 8, so x equals 8. So I know every time that I plug 0 in for y, then I'm going to put positive 8 for x. So now I have to substitute in my negative 8 for x. So good news, this is just like I did all the way back in example A. So the first thing I'm going to do is substitute in my negative 8 using parentheses. So I've got negative 8 inside parentheses minus 8 divided by negative 4 equals y. So I'm going to do the order of operations. I'm going to do everything on the top first, and then everything on the bottom. So negative 8 minus 8 is going to give me negative 16. All divided by negative 4 equals y. Then I have negative 16 divided by negative 4. Negative divided by negative is a positive. Negative 16 divided by negative 4 is positive 4. So I've got y equals 4. So every time I plug in negative 8 in this linear equation, I'm going to end up with y equals 4. Alright. You're going to pause the video now, plot your points, and graph your line, then unpause to check to see if you are right. How'd you do? Hopefully you remembered to draw the arrows on the end of your line, because remember, not just the points that we have in our table work for this equation. Any set of points on this line work for this equation. Let's take a look at the next one. So the next one says, given our linear equation, complete the table, then use the ordered pairs to graph the equation. All right, we're getting pretty good at this. Wait, y equals 4? This time we only have one variable, y equals 4. No x's, nothing to do. So what are points that we're going to pick? We know no matter what we pick for our x, y is always going to equal 4. So I'm going to put a 4 for y every single time because I know no matter what, y equals 4. Y equals 4, y equals 4, y equals 4. It doesn't matter what x's I pick because in this case, y is always going to equal 4. If I put x as negative 5, y still equals 4. If I put x as 0, y still equals 4. If I put x as 7, y still equals 4. If I put x as negative 45 billion, y still equals 4. So let's see what this does to our linear equation, because again, it's always going to graph a line. So let's see if it still graphs a line, even though I only have one variable here. So every time, let's see, I've got negative 5, 4. So over to negative 5, up to 4. Okay, 0, up to 4. 7, up to 4. So look, my linear equation still holds true. It's still made a line. It's just this line is going to be horizontal. So again, it made a line all the way through my graph, just like every other linear equation. It's just this line is horizontal. But again, I'm going to draw my arrows because not just the x's that I picked here, but as we talked about, all the x's are always going to give us y equals 4. Let's take a look at the next one. Alright, this time it wants us to graph linear equations with one variable, but this time it gave us x equals negative 7. So I know no matter what I pick for y, my x is always going to be negative 7. So x will equal negative 7, x is going to equal negative 7, x is going to equal negative 7. Now again, it doesn't matter what I pick for y's, it doesn't matter whether I pick negative 5, if I pick 0, if I pick 7, it doesn't matter what I pick for y, because no matter what, my x is always negative 7. So let's see, again, does this make a line in our linear equation? So I've got going over to negative 7, down to negative 5. Again, I'm going to go over to negative 7 and stop at 0, and over to negative 7 and up to 7. So again, I've made a line for my linear equation. It's just that this line is going to be vertical because every single point along that line is going to be x equals negative 7. So I'm going to again draw my arrows because again, not just the numbers I picked here, but any numbers on that line will always equal x equals negative 7. Let's take a look at the last practice. Alright, independent practice. On one side you got x equals 1, and on the other side y equals negative 2. I want you to pause the video now, complete the tables, and graph the lines. When you're done, unpause the video to see if you are right. Okay, check to see if your answers are right. Now, did you pick the same x's or y's that I did? Probably not. On the left side, you could have picked any y's you wanted. On the right side, you could have picked any x's you wanted. They may not be the same, but what should be the same is the lines and the graphs. Those do not change. The linear equation is the equation. Again, no matter what numbers I pick on the line, they will still be on there. So make sure that your lines and graphs match. Your tables may not, because again, you probably didn't select negative 3, 2, and 0, just like I did. But as long as your lines and graphs match my lines and graphs, you did it correctly. This is the end of the notes. Now go ahead and work on your Google Classroom activity. If you like this video, throw us a thumbs up. If you love this video, throw us a sub.